Thanks again for coming to the session from data to diamonds, unearthing the true value of quality data for ML. And we're going to be specifically focusing on computer vision use cases or applications there. So a bit about me. My name is Stephen Oladele. I'm a developer relations engineer at Encord. Encord is a data-centric computer vision platform. We help institutions like the British Defence Force, medical analysis companies, and so build computer vision solutions. And on Encord, you can do data annotation as well as build computer vision models on your data on just one single platform. So my background is in deploying ML models. I was previously a machine learning engineer before switching into the role as a developer relations engineer. That was really where I got to understand all the challenges around deploying ML systems. And sorry, no, please go. And I'm also excited about communities, DataFest community, AI, AWS MLOps communities. These are all. I've been an avid community contributor for a really long time now, so it's always exciting. And beyond that as well, I've mostly worked with AI startups. So these are startups building ML platforms, ML solutions to really take your models from development to deployment, monitoring the models, and pretty much automating the entire process. So thanks again, that's enough about me. So yeah, today's agenda, we're going to be talking about why data quality is important for your use case, why data quality is often bad, and then we're also going to be going into the workshop. You know, we're going to be exploring a use case data set. You're going to be seeing how you could really think about going from just data, which is usually really messy, to turning those into something really useful, or what we call it here, the diamonds. And yeah, tips for fixing data quality data. So obviously, we are in the dawn of AI here. LLMs, GPT-4, ChatGPT, pretty much llamas and stuff like that. There's been an exponential growth, as you've seen, in the publication of ML papers over the past few years. Over the last 2 years, just 2022 and 2023, a lot has changed in the field, from your role as an ML engineer to, how you do research and all of that, and what you actually research on. It's been a profound leap or exponential leap in the AI world. Obviously, you're seeing, pretty much practically all of us use ChatGPT now. So we see how valuable it is. There's the Tesla the Tesla self-driving, fully self-driving cars that have gotten so good. And then obviously you're starting to see a lot of AI in weaponry. It's an avid era we have right now in ML. So yeah, AI is becoming exponentially useful, but what is stopping it? Yeah, and this is what we're going to be talking about. And how do I call it now? Spoiler alert, it's the data quality. So yeah, we've seen companies make progress in AI. Companies have to cross a big gap to make progress in AI. Why is that? We are seeing a lot of progress with LLMs these days, with vision foundation models, SAM, segment anything, and all of that. But there's still very, very little. It's pretty much just 10% of the companies that are meant to use this thing. Over 100% are actively getting the use of AI. So we are at this point where we're at this point where we are done just the AI part, meaning we're making a ton of progress with AI. And then, we need to get to the point where we have useful AI. So this gap here is what we're going to be talking about today. So yeah, a lot of what's between this gap here, you have no data. Companies practically have no data, right? There are a lot of companies that don't have data sets to really leap into or tap into the usefulness of AI these days, how much AI, large language models, visual foundation models are progressing. Then you have robustness, meaning your use case isn't particularly what Meta sort of considered when they were building segment anything model or object detection models that are very, very useful today. And then model tuning, it's an incredibly hard problem. You need a ton of GPUs, compute power to be able to fine-tune models properly, to be able to use the leap that AI has afforded us over the past few years. Explainability as well. There's a key reason why most companies are not open sourcing their models these days because it's really, really, it's very hard for them to really sort of the Lego issues that could come with using these platforms, especially open sourcing them, can cause a lot of issues. And then there's what we call operational cost. How do you continually run these models in production? It can really, really get costly. I was talking to a founder of a machine learning platform quite recently, and he was mentioning how operational costs can really skyrocket. And then there's also reliability. How do you ensure that 99% of the time or 99.99% of the time your systems are reliably up, right? And that this is obviously on the operational side as well, but it's crucial that this is one of the key reasons why companies can't take a leap from just AI, meaning tapping into the progress of AI, into making it a useful AI for their use cases. And then there are edge cases, right? Like I mentioned, there are cases where segment anything hasn't been trained on your company data. In most cases, that's going to be how it is. So how do you ensure that you can cater for these edge cases to progressively use AI? And then there's generalizability, generalizing to problems beyond the scope of the data set. And then outliers, outliers, edge cases. And then there's the bias as well. These are the reasons why companies can't really go from the AI progress into tap into the AI progress and to make it useful for their use case. Thank you. So what's the common theme between that particular chasm? Yeah, we see it's data, right? There's no data, practically data. Reliability as well, practically data. Outliers, data is a problem there. But when it comes to the edge cases as well, these are all, data is at least a part of some of these problems there. And we know, obviously, there's the cliche that data is the new oil, but how do you typically take that oil and refine it into a use case, into a particular asset that can be useful for your company or for your organization and stuff like that. So what's the problem with data, right? What's the problem with data these days? Can anybody share? What do you think is the problem with data these days? Huh? Too much of it. Okay, that's one. Huh? Oh, too many debts, too many technical debts. Okay. Huh? Okay, it can be expensive to come by sometimes. That's it. Anybody else? Okay. Huh? Integrity of the data. These are all problems that we're having today. But definitely one problem is that it's not so much of it that's the issue. Right? We have a barrage of data. Obviously, if you know the statistics, the internet generates as many data as possible. The exponential rates that data is going to be generated and has been generated over the past few years, and it's going to be generated, is just something that we cannot comprehend. We are losing track at this point. Even our chips, the compute chips, the storage chips, the things that are using to be compute these days are running out of storage pretty much. Yeah. So there seems to be too much of it. So let's see. So in 2022, they were like 97. And by the way, I used ChatGPT to generate this. So if it's wrong, blame ChatGPT, please. So in 2022, there were like 97 zettabytes of data. That's an enormous amount of data. And by 2023, it's estimated that by the end of 2023, we'd have nearly 3 times the volume of data generated in 2019. So it seems to be like there's just too much data for us to handle at this point. So more specifically in image data sets, there are like 1.7 trillion images taken every year. And then there are 1 billion videos watched daily. YouTube and everything, these things are generating data. And then surveillance cameras and everything. So there's not a lack of it at all in most cases. So too little valuable data. This is where we are, right? We have so much data sets out there, but how can we make it valuable is the key concern here. So let's go to really understand why improving data quality is important. Right? As you mentioned, data is the new oil. And as machine learning engineers, as data scientists, as data engineers, more specifically as data engineers, our job is to really get the data set and refine it, right? And if you see, no matter how you put any ML system, any AI system at all, there are practically 2 things that are involved, yeah? You have the code and you have the data, right? These are the two major components of building or two foundational components of building any AI system, right? So whether it's the traditional systems that, your support vector machines, your deep learning, traditional deep learning, or large language models, which are the modern deep learning, modern AI systems these days, code and data sets are hugely important. So you can't take away the data, right? And I think sorry. I think I really love this quote from one of the curators of AlexNet. He's one of the founding fathers of deep learning. And he did mention that it is much more effective to evaluate, and improve your data. That will be every company's competitive advantage. Now, everybody has access to LLMs, right? You can pretty much, if you have, the necessary compute, you can get open source large language models, or you can just use GPTs, open APIs, API, and stuff like that. So everyone has equal access to it. But what can be the competitive advantage is how you can properly refine your data sets as well. Okay, just gone. So let's look at some of the key reasons why, data quality, improving data quality is important. So real-world data set is not like in academia. I'm sure most of you know. So for example, some of you who worked on cargo problems, you worked on Zindi Africa problems, and then you got to be employed into an actual industry, and then you realize that real-world data sets is quite different, from traditional data sets. So you would encounter data errors. In fact, most of the time, you're going to spend a lot of time, God even help you, if you're the only data scientist in your company, you're going to be spending a lot of time really cleaning your data set, really trying to, because everything downstream won't work if your data set doesn't work properly. So you have to clean your data set of errors, duplicate images, broken images, outliers, edge cases. These are things you have to get rid of. And then you have labor errors, right? God help you as well, that you have, an expert. Maybe you might be working in the medical industry, and then there's a medical professional that helps you annotate. The person is going to be bound to make mistakes. So and those mistakes will inevitably affect your system downstream. Your manager wouldn't want to hear that it was the SME that made a mistake. You beat the model, right? So these are all key things that you have to know. Missing labels, inconsistent labels, class imbalance, and things like that. And then obviously there are edge cases. There are cases where you've not gathered a subset of data properly. Maybe, for example, you've not gathered a particular data set that can solve one part of the problem properly to be able to train the systems or fine-tune the systems to work well. And then there's the problem of data drift as well, where you've trained your model on a particular data set, and then when you deploy it to production, a different data set in production is affecting the performance as well. It's gone. So there's also this is an example, right? Ordinarily, you probably trained a particular system to detect plastic bottles, and it was clean, right? You got all the plastic bottles and you trained it properly. But assuming you're trying to detect the plastic bottle in this case now, it can be very difficult to see what's out there. And this is a particular edge case because this particular woman is just, your model has probably not seen this particular this thing. I cannot generalize to this particular case before, right? These are also issues, this is a clear food container. Is it really clear, or, is this particular one buried in the sand as well? These are all edge cases that if you don't improve your data quality properly, no matter the state of the art model you use, you don't get the valuable result or the useful AI out of it. Thank you. And then there are empirical results. So this is like the uncertainty learning in this case. So so these are pretty much when you talk about you're doing research and then you're doing what we call research engineering. There are a lot of empirical results that you need to be able to improve, and data quality is really crucial. If your data is not really good, whatever learner you're training won't be able to give you the actual results. And then because Elon Musk says so, we are probably all fans of Elon Musk, so some of us that are socialists may not be. But yeah, data is a really crucial part of even improving the fully self-driving cars problem. And of course, bringing it locally as well. It's pretty much the same thing, right? If you're building an object detection system for your company locally here, even here that we have to take care of the data quality more than that's being done in the West, because we have a lot of edge cases here, from the person's tone of the skin to, different things. You just see people doing wild things. You've watched surveillance before, and you realize that, oh dear, you train your system on one thing, and then your user is using it differently. So these are all things that we have to take a note of. So how do you go from data to diamonds? And that's what we're here to talk about today. So I've sort of broken this down into a 5-step process to assessing and improving data quality, and most specifically focusing on computer vision use cases. Obviously, I had to hone it down to computer vision here, because in this case, you can, obviously there are different tasks: natural language processing, audio detection, that's a whole semester of course in its own. So for now, let's just get high level, focusing on image data sets. Right, so what are the 5-step processes from moving from data to diamonds? First of all, you define your objective. This is something you're familiar to. If you're working as a data scientist already, right, you need to, before you go into building your models, you need to be able to understand from a stakeholder perspective what models make sense, what data sets make sense for you to work on, how the particular objective, both on the technical side, meaning you're defining the objective for your machine learning model to learn, as well as the objective for the business to get value from, if the business is, in fact, get value. So these are typical project management listing. And then you have curate and annotate your data set, right? This is practically not, if you don't have this sorted out, everything downstream is practically worthless. And then you have computing image embeddings and training objective quality metrics on the embeddings itself. So for you to be able to work with image data sets and be able to go through the process of fine-tuning and refining them, you need to be able to convert them into embeddings, right? And this is a really, really hard problem. This is an NP-hard problem on its own, right? That computer scientists are spending a lot of PhD years solving. And then you need to also identify the image quality issues. This is something you probably do already, where you explore your data sets. You do exploratory data analysis to unearth patterns or unearth problems with the data set. And then you have to fix the image quality issues. So let's go into these 5-step processes one-on-one. Okay. All right, let's go. Define your objectives. So what problem are you trying to solve? This is really, really crucial. If you don't understand this first off, the downstream systems are pretty much bound to fail. Then you need to be able to understand how would the solution be valuable to the business, right? So for some of you that are, business analysts or, even as engineering managers, sometimes you need to be able to work with your founders or co-founders or managers to be able to define the business metric. How would the solution be valuable to that particular business? And then what type of, you start to get into the technical details, like, well, if you've been able to establish this, if you've established it as well, you get into what type of ML solution do you want to, would you use to solve this problem? So that's where your expertise as a data scientist or your expertise as an AI engineer or ML engineer really starts to shine through, And then how would an ideal solution really perform? So this is you really setting an expectation of, on the user side, what should they expect? Is it going to increase user satisfaction, or is it going to help speed up internal systems? So let's go through an example, so I don't just talk in abstract terms. So let's take an example of of a company and let's start with understanding what is the problem they're trying to solve. And let's technically say dog breeds are classified as food in the company's image search engine. So maybe this particular company, whenever a user searches for dog breeds or food, image search. I don't know how many of us have used image search before? Image search systems. Yeah, for example, maybe when a user is searching for similar food and stuff like that, and then it's being classified as dog breeds, that could be a problem itself. So how would a solution be valuable to the business? So in this case, we're looking at reducing or completely eliminating the number of user complaints, because each time that happens, users get to complain and say, hey, my food I was trying to search for food and then I was getting dog breeds back, right? And then, and obviously in the KPI, you might just say minus 75% and reduction in the number of user complaints. And then you're looking at what type of ML solution would solve this problem. Let's technically just say, although obviously there are nuances around this, but at a high level, let's say binary classification. Now, what type of data is available that adds values to this particular project? Obviously, these steps are not as easy as I'm saying them. Okay, perfect. So this is an example of, if you're working with an image data set, if you're doing object detection and stuff like that, you need to be able to gather images. Say, for example, you're looking at detecting plastic bottles, right? You have to gather images and then have to annotate them, meaning you have to draw bounding boxes. For some of us that use data annotation platforms, shameless plug Encord. So, we also have a community. If you're interested in community, if you're interested in active learning, improving vision quality, you can check out our community and Slack here. Again, like I mentioned, I'll be able to share this.